Hello, my name is Rasaminta Hussain, student ID 1606151. Our EEE 416 project is Bangla Digital Clock. For this project, our goal was to implement a Bangla Digital Clock using ARM Cortex-m series board. We have to display the time using a LCD display or LED matrix display. We also have to use buttons to adjust our minutes and seconds. We have successfully fulfilled these goals. As for the bonus part, we couldn't implement the hardware part due to the current situation, but we have added AM/PM in our clock. Bangla is the mother tongue and official language of Bangladesh. So it is a very good idea to use Bangla in digital clock, which is used on regular basis by all kind of people. And some of these people may not find English comfortable as the display language. While implementing this project, we have used STM32F103R6 as the microcontroller. STM32 CubeMX is used to set up the pin configuration and system clock configuration. ARM Kale was used to build and debugging the coding part of the microcontroller. And as we do not have any physical circuit, we have used Proteus to show the circuits. We also use Proteus to design the PCB of our project.
Hi, welcome back. CubeMX and MDK together builds a very strong ARM Cortex environment. CubeMX is a very advanced peripheral library where we can set the peripheral and clock settings to get an initial code. Firstly, we have to set the pin configuration in CubeMX. This must integrate with our hardware settings. For example, according to our hardware implementation, we have set the port B1 to port B7 in output and port C1 to port C3 in GPIO input setting. We, we should also set the mode of each port. Since our ports are directly connected to ground or source, we have set the mode to no push pull mode. We have also enabled the RTC interrupt. The system tick is also enabled, so there are two timers. One is the RTC and another is the system clock. The system clock basically comes from the 4 megahertz Cortex system timer. So our will be two implementation. One will be using the interrupts of RTC and another will be using the interrupts of Cortex system timer. Once these settings are made, STM32 generates an initial code with the peripheral and clock setup. On top of the initial code, we can program according to our need in Kale UVision. Thank you.
My ID is 1606147. Here, after using the STM32 MX, we have generated the code and used KIDE to control our STM32 microcontroller. Here, to know the sequence, we have to first understand how we have defined the Bangla characters from 0 to 9. Here, we can see that Bangla ek is supposed to be like that in LCD character. In LCD, we know we have 5 into 8 matrix. If we want to generate one Bangla 1, then we have to shape this as 1 in binary 1 0 0 0 0, and for the second line this should be 0 1 0 0 0. Third one should be 0 0 1 0 0. This binary codes has been converted to hexadecimal like this, and in that way Bangla 2, Bangla 3, Bangla 5, Bangla 6, 7, and 8 and 9 has been generated. But the Bangla 4 and Bangla 0 are English 8 and English 0. So that doesn't has to be created by our code. We can use English 8 as Bangla 4 and 0 as English 0. In this code segment, we have defined these characters. After defining the characters, we have defined LCD number functions and the number printer functions to define the position of every minute second digits. Here we have used the system tick handler to use the system clock. Here we have used the liquid crystal function to interface our LCD. Here is the create character function. What is the argument? Takes the number of the name of the array and the number we want to print with this array. After creating those Bangla characters, defined we have defined states and the push buttons for configure our digits like minute and hour of our digital clock. If we build this code from here and go to our Cortex, if we simulate this, we can see our Bangla digital clock is up and running. If we want to change the time to our current time, we have to change the menu first to change minute. If we want to show the correct time, the recent time, we can use the push button connected to PC2 to increase the value to the current time, which is 24 minute, and if we want to minus, we can use this push button. Then if we want to change the hour settings, we can change the menu to change hour, and we can plus or minus as our requirement of current time. Then we can again change the menu to AM or PM as our requirement. And then if we change the menu again to the display time, the clock starts from the current time. That is our project.
Here is the designed PCB layout of our project. This is the PCB. It's a bilayer PCB. Its dimensions are 75mm cross 56mm. It is the 3D rendered view of our designed PCB. It is the top view of the designed PCB. It is the top silk. It highlights the position of the components that will be placed on the PCB. This is the top copper. This highlights the traces that will be on the upper layer of our designed PCB. And here is the bottom copper. This highlights the traces that will be on the bottom side of our designed PCB. Here is the 3D visualization of our PCB layout, and this is the PCB that we have designed. This project can be extended further in the following directions. For showing time, we would have used the LED matrix display, which would have made this project more alluring. Also in this project, we have used RTC, real-time clock, embedded in the STM32 for displaying the time, but we could not change the hour, minute and second using the RTC. For that, we have to use RTC interrupt coding in the coding part. This can be an interesting extension to this project. Moreover, inclusion of time zone would make this project more realistic. Last but not the least, we could have used OLED script to make this project more interesting. For implementing of digital devices in our native languages, we will make this product more user-friendly for mass people. Moreover, in this project, we have used an up-to-date microcontroller called STM32 from Cortex-m series. Besides, the advantage of changing the hour, minute and second button and as AM and PM button will make this clock a dynamic one. Also, this project incorporates a menu layout which will make the user more friendly with the clock. In conclusion, it can be said that furnishing this project a little more would make it a profitable market product. That's all from my side.